I won't dance, don't ask me. I won't dance, don't ask me. I won't dance, madame, with you. My heart won't let my feet do things.
At the end of this review session, I need you to be able to solve equations, specifically quadratic equations. And the techniques you're going to need are completing the square, the quadratic formula, approximating solutions graphically, and approximating solutions numerically using tables. Okay, let's get started. I'd like you to try solving this equation using the quadratic formula, then by factoring, then by completing the square. I'd like you to stop the video now and start it again when your work is complete. Let's first try using the quadratic formula to solve this equation. You should have the quadratic formula memorized by now, and if you don't, there's a simple song that will make it unforgettable. Remind me to demonstrate it one day. Comparing our given problem to the standard form for the quadratic, we find that a equals 1, b equals -1, c equals -6. Plugging these values in for a, b, and c in the quadratic formula, square root of 25 plus or minus, we got to make sure we take into both. So our two answers are going to turn out to be 3 and a -2. Now let's try a different technique. Let's try factoring this time. I need two numbers whose product is a -6 and whose sum is -1. -3 and +2 will do, so solving each part of this equation for 0, I get 3 and -2 for solutions, which is exactly what I expected. Finally, let's try completing the square. Remember, when you're completing the square, that you were to add the term b over 2 squared to both sides of the equation. In this example, it turns out to be 1 over 4. So we add that to both sides, which makes the left side of the equation a perfect square. In this case, x minus 1/2 and x minus 1/2. So it's x minus 1/2 squared. Solving for x, making sure I take into account the plus and minus, my two answers turn out to be, I hope, 3 and a -2. No surprise in our answers. Please remember that all three techniques are necessary, but I used all three on the same equation to demonstrate each one and to show that each will work well. Now I'd like you to try using the same techniques on a different example, but I would like to change the order. Please try completing the square first, then factoring, and finally using the quadratic formula. I'm not asking you to do a second problem just for practice. There is something here I need you to see, so if one technique frustrates you, just stop and try a different one. Please pause the video now until your work is complete. First, we're going to try completing the square. We need to add b over 2 squared to both sides of the equation. In this case, that turns out to be 9. We add 9 to both sides of the equation to make the left side a perfect square, and in this case, it's x minus 3 and x minus 3. Solving for x, we get, square root of both sides plus or minus. We get 3 plus or minus the square root of 7. Alright, that is odd, so I'm going to try factoring it. I need two numbers whose product is a 2 and whose sum is a negative 6. Um, no, okay, that's no good. Finally, we'll try the quadratic formula. In this case, x is 1, b is negative 6, and c is 2. Substituting into the quadratic formula, I'm going to get the square root of c. Simplify square root of 28. Think 28. Yeah. Simplify the radical, and the solution turns out to be divide by 2. 3 plus or minus radical 7 and 3 minus radical 7. The two solutions are the reason I wanted you to try this example. We did get the same answer using at least two techniques though. If I try to solve the first problem using a graphing calculator, then I should get the same answers I got using algebra. I will turn on the trace function and examine the roots of this equation, and that's where the function intersects the x-axis. Looks like one point is negative 2, 0, which would mean that the function is equal to 0 when x equals 2. If I move my crawling spider over to the other root, then I find that the function's equal to 0 when x is equal to 3. And that's good news, because those are the same answers I got algebraically. Now let's try that same technique on the second equation that gave us the unusual answer. Let's see, if I turn on my trace function, I'm going to try to put the spider over the two roots of the equation. I'm going to go to the right first and find that the one root is trying to get the second number there to equal 0, the y value, but I can't seem to zoom in on it. Let me try the other one. Again, I can't quite get it to equal 0. It gets small, but I can't quite get it there. I think what I'm going to do is I'm going to look up a table. Like if I took out a piece of paper and made up a table for this equation, where does this function equal 0? When does the second number equal to 0? And looks like it goes from 2 to negative 3. Let's see. Yeah, I can't. Somewhere between 0 and 1 it looks like. Let me try the other root. It goes from 2 to negative 3 between 5 and 6. It goes from a negative to a positive. I'm going to set the table settings a little smaller this time. I'm going to start at 5, and I'm only going to go by 0.1 each click. So let's see, I go from positive to a negative. I'm trying to find 0. And it looks like between 5.6 and... I'm going to try the graph again. Let me see. If I go to the second root, the one that's around 5, on my table, it looks like 0 is between 5.6 and 5.7. The lowest I can get is about 5.65 on my trace. I'm going to try zooming in on that. I'm going to click it a couple of times and zoom right in. And then I'm going to turn on my trace function so that each move is a little bit smaller. I'm trying to get it right on 0. I can get it smaller. I went right off the graph that time. Smaller and smaller. I can't seem to get it right on 0. Like 5.65 is the best I can seem to do. That's, wow, 11 zeros and a 2. That's a small number. Let me try. Gotta find out where the 0 is. Let me try changing the table again. It's 5 point something. Let me try 5.56 and go by hundredths this time. And then when I go through the table, where does it go from negative to positive? Wow, this is really unusual. Some of my answers in homework turned out so nice. Somewhere between 5.64 and 5.65. You know what? I'm just going to use the calculator to figure out what those two roots are. So 3 plus the square root of 7 turns out to be about 5.64. And the 3 minus square root of 7 turns out to be about 0.35, which is exactly what we got on the trace function using the graphing calculator. And so I used 5 different techniques to solve 2 given problems. Now I need you to be able to apply these techniques to any problem you are given. Thank you for your time and attention.
That music leads the way to romance.